The planets in our solar system started forming billions of years ago and went through different processes, which make them as they are today. First, our solar system formed over 4.5 billion years ago when a giant gas and dust cloud began to collapse in on itself. The gas cloud collapsed into a flat spinning disk, and the sun formed at the center of this disk. This flat spinning disk explains why all the planets are on the same orbital plane and orbit the sun in the same direction. Next, the formation of the planets took place, starting with accretion. When the solar nebula began to collapse, the gas and dust condensed into small particles. The particles stuck together through electrostatic forces. Once the particles were large enough, they were able to attract other particles via gravity. As the particles grew in size, they attracted larger and larger masses. When two bodies attract each other, they collide and merge together, which is accretion. Particles accrete to form planetesimals, planetesimals accrete to form planetary embryos, and planetary embryos accrete to form planets. The colliding of planets from accretion generates a lot of heat, which leaves the planets molten hot when they first form. The planets then go through differentiation, which is where gravity pulls the denser elements to the center of the planet and the lighter elements move to the surface of the planet. This is what forms the layers of a planet. The material must be liquid and able to flow in order for differentiation to occur. Once a planet has cooled and the material is no longer liquid, the planet cannot go through differentiation anymore. All planets in our solar system have gone through accretion and differentiation. However, there are two different types of planets, terrestrial and Jovian. Terrestrial planets are small, dense, rocky planets, which are closer to the sun, while Jovian planets are large, gaseous planets, which are much further from the sun. The reason for these two different types of planets is the frost line. The frost line marks the boundary where liquid water can condense. Close to the sun, it is too hot for liquid water to condense. Only metals and rocks are able to. As temperatures begin to decrease further away from the sun, water is able to condense into ice, in addition to the rocks and metals. The frost line marks where temperatures have decreased enough for condensation of water, which is between Mars and Jupiter. Since only rocks and metals can condense inside the frost line, the terrestrial planets created here are smaller and denser than the Jovian planets. Since ice, in addition to the metals and rocks, is able to condense outside the frost line, there's more materials for the Jovian planets to accrete from, resulting in larger planets. Also, since the Jovian planets are able to get larger faster, they were big enough to be able to start pulling in leftover nebular gas, which further increased their size and gave them their gassy composition. The planetary formation ended when there was no more materials left for the planets to accrete from, and the solar winds blew away all the remaining nebular gas that was adding to the gaseous planet size.